Welcome to the Explainer. Today, we're cracking open the source material on something absolutely wild, one of the most complex engineering feats on the planet. I'm talking about the invisible magic operating right behind the glass of your screen. You know, that massive machine learning architecture powering the internet ads we see every single day? Let's get right into it. So think about this. What actually happens in the blink of an eye when you just scroll your feed or type a quick search? It feels completely instantaneous to us, right? But the second you swipe, you're kicking off an incredible, hidden journey across giant data centers. And the sheer scale we're dealing with here, it is staggering. This system architecture handles roughly 1 million ad queries every single second. 1 million. That means it's evaluating millions of campaigns and hundreds of millions of creative assets constantly, non-stop. But here's the kicker. It has a hard latency budget of under 100 milliseconds to do the whole shebang. So before you even have time to blink, this system has to retrieve the ads, score them, run a literal financial auction, filter out the fraud, and deliver the winner right to your screen. No pressure, right? All right, here's our roadmap for decoding this massive pipeline. We're going to cover 1. The millisecond marketplace. 2. Finding eligible ads fast. 3. Predicting clicks and conversions. 4. The invisible ad auction. 5. Combating fraud and bias. And finally, 6. The ultimate balancing act. Let's jump right into Section 1, the millisecond marketplace, a three-way tug of war. Now, to really grasp this ecosystem, you have to realize it's built on constant tension. The system is essentially acting as the ultimate mediator between three very different stakeholders. We've got the users, us, who just want relevant, non-intrusive ads, a good experience. Then you have advertisers who desperately want a strong return on investment within their budget. And finally, the platform itself, which needs a healthy marketplace and sustainable revenue. If you squeeze just one of those groups too hard, the whole ecosystem falls apart. So how do they mathematically balance all these competing desires? Well, they use a metric called ECPM, or expected cost per mil. You see, serving an ad isn't just about handing it to the highest bidder. That would ruin the user experience. Instead, the expected value multiplies the advertiser's bid by the probability of a click, that's the PCTR, and factors in an ad quality score. This brilliant little equation ensures that a highly relevant, high-quality ad can actually beat out a high-paying but super annoying one. Moving on to Section 2, finding eligible ads fast. The funnel begins. Okay, our 100 millisecond countdown officially starts right here, dropping into this massive architectural gauntlet. Basically, a request flows from the ad server into a retrieval phase, then it gets pushed through some incredibly intense machine learning scoring models, right into a live auction, and finally out to fraud filters before returning a winner. It's a crazy ride. It all kicks off with a single ad opportunity triggering the ad server. Instantly, a retrieval process fires up. Out of millions of possible ads out there, it uses advanced search indexes and embeddings to rapidly filter everything down to just a few thousand eligible candidates. It looks at targeting, it looks at budgets, and it just instantly clears out all the noise. Which brings us to Section 3, predicting clicks and conversions. The need for absolute accuracy. We are now deep in the heavy machine learning phase. And here's the thing, if this were just a simple recommendation engine, ranking, just putting the best video first, would be totally fine. But because we're talking about real money and live pricing, just putting things in the right order isn't enough. The system requires calibration. It needs absolute mathematical accuracy. A miscalibrated prediction will completely break pricing and pacing, even if your ranking order is spot on. Think about it. If the model predicts a user has a 5% probability of clicking, that prediction must mean exactly 5% in the real world. If it's wrong, even by a tiny bit, the math fails, advertisers end up way overpaying, and the platform's entire economy just breaks down. So to nail that exact percentage, the models have to process an insanely dense amount of data in like less than 10 milliseconds. We're talking user features like historical click rates, context features like what time of day it is, or the page position, and advertiser features like the current state of a campaign's budget. Thousands of these signals are mashed together to forecast exactly what you are going to do next. All right, Section 4, the invisible ad auction, pricing and pacing. Let's walk through the exact steps of this invisible auction. Step 1, the system ranks all eligible ads by their ECPM. Step 2, it applies reserve prices just to maintain a baseline of quality. Step 3, it uses a second price logic to compute the final price.
But step four is fascinating. It applies pacing multipliers. See, pacing is this massive control system that throttles bids. Without it, an advertiser might accidentally blow through their entire daily budget in the first 5 minutes of the morning, and nobody wants that.
Now, this does bring up a really unique problem called the cold start trap. Put yourself in the shoes of a brand new advertiser. Because the system has no historical data for your shiny new ad, the machine learning model kind of shrugs and gives it a low rank. But a low rank means 0 impressions, which means you never get any data. It's a vicious cycle. To fix this, the system deliberately uses an exploration budget. It actually takes a short-term revenue hit just to give those underdogs a chance to be seen and gather that crucial data.
Moving on to Section 5, combating fraud and bias, keeping the system honest. Because, look, a perfect machine learning algorithm is completely useless if the clicks aren't actually real. This system absolutely has to maintain advertiser trust at all costs. If an advertiser figures out they're paying for bot clicks, they're gone. So real-time detection systems are constantly acting like bouncers, actively sniffing out bot farms and click fraud and invalidating those sketchy events before the advertiser is ever charged a dime.
The system also wrestles with this massive headache called delayed feedback. Say you click an ad for a new pair of shoes today, but you wait until tomorrow to actually buy them. If the model only looks at real-time data, it's going to think that ad failed to convert. So the models must actively account for these delayed conversions. Otherwise, they'd end up severely underbidding in the future. It's a really tricky balance.
And that brings us to Section 6, the ultimate balancing act, system trade-offs and failure modes.
As our 100-millisecond clock is rapidly ticking down to 0, immense structural safeguards have to be in place to prevent a total catastrophe. If the calibration drifts, the platform misprices everything and just hemorrhages revenue. If the pacing lags, advertisers overspend and lose trust. And what if there's a sudden latency spike where the deep learning model just takes too long? The system will immediately fall back to a simpler, much faster model rather than missing the auction entirely. There are safety nets everywhere. So, the absolutely crucial takeaway from this whole explainer is that mature platforms are making very deliberate trade-offs. They cap ad load so we, the users, don't get totally annoyed. They prioritize mathematical calibration over just raw ranking accuracy. And most importantly, they know that squeezing advertisers for short-term revenue destroys ROI and ruins the entire marketplace in the long run. It's a long game.
Which leaves us with this final thought. We've just peeled back the layers on this incredible engineering scale. The billions of calculations, the delicate economic balancing acts happening every single time you swipe your screen. If you had less than 100 milliseconds to decide what the world sees next, how would you balance the scale? Thanks for joining me on this explainer. I really hope it gave you a totally new perspective on the invisible machinery of the internet.